Good day, everyone. My name is Zpei. Thank you for joining me today. In this presentation, I will be guiding you through an experiment involving neurofeedback training using EEG technology. Throughout this session, I will explain what neurofeedback is, how a session is conducted step by step, the equipment involved, and how specific brainwave frequencies are selected. I will also highlight the outcomes of the session, current technologies in neurofeedback, and future applications of this technique. Let's begin our journey into understanding how we can train the brain using science and technology. Neurofeedback, often called EEG biofeedback, is a scientifically validated method that teaches the brain to regulate itself more effectively. It is grounded in the principle of operant conditioning, where the brain receives real-time feedback about its electrical patterns and gradually learns to shift toward healthier rhythms. Each time the brain produces a desirable pattern, such as relaxed alpha waves or focused beta waves, the system rewards it through smooth visuals or pleasant sounds. Over time, the brain learns these patterns naturally. Next, EEG, or electroencephalography, is the technique used to measure electrical activity from the brain. Sensors placed on the scalp detect tiny voltage changes caused by neural firing, which appear as brainwaves of different frequencies like delta, theta, alpha, beta, and gamma. These frequencies reflect mental states such as deep rest, creativity, calmness, concentration, and heightened alertness. Furthermore, quantitative EEG, or KEEG, provides a deeper layer of scientific analysis. It uses advanced software to compare a person's brainwave patterns to a large normative database. This helps identify regions that are underregulated or overactive, guiding practitioners in choosing the most appropriate neurofeedback protocol. In essence, neurofeedback transforms brain activity into interactive feedback. When the brain performs optimally, the feedback system rewards it. When it diverges, the reward decreases. With repetition, just like training a muscle, the brain develops stronger, more efficient pathways. Neurofeedback training works by creating a closed-loop system between the brain and a computer. First, EEG sensors measure the brain's electrical activity in real time. This information is immediately processed by neurofeedback software, which identifies whether the brain is producing more or less of the targeted frequency. When the participant's brain generates the desired pattern, such as increased alpha for relaxation or increased SMR for focus, the system provides a reward, usually in the form of clearer visuals, smoother animations, or pleasant audio tones. When the brain shifts away from the target pattern, the reward reduces or stops. Through this moment-to-moment feedback, the brain subconsciously learns which patterns lead to reward. This process is based on operant conditioning, meaning repeated reinforcement strengthens the desired neural pathways. With consistent training, these optimal patterns become more stable and automatic in daily life. So, let's move into how a real session is conducted. A neurofeedback session begins with preparation and setup. The practitioner prepares the EEG equipment, checks the system for signal quality, and ensures the client is comfortable. The goals of the session are explained clearly so the client understands the process. Next, electrodes are placed on the scalp using conductive gel or paste. The placement depends on the target brain region, such as central areas for SMR training or frontal areas for attention. Impedance is checked to ensure the signals are clean and reliable. Once the electrodes are in place, a baseline EEG is recorded. During this stage, the client sits quietly while the practitioner observes natural brainwave patterns. This baseline is essential. It allows the practitioner to identify excessive theta, weak alpha, or overactive beta patterns. This information guides the selection of the training frequency. The neurofeedback training then begins. The client views an animation or game that responds directly to their brain activity. When the brain produces the desired pattern such as increased SMR or reduced theta, the animation moves smoothly or the game progresses. If the brain shifts away from the target pattern, the movement slows or stops. This system teaches the brain to maintain healthier states through continuous reinforcement. Finally, the practitioner the brain trainer device performs analysis. It tracks the amplitude of different frequencies, measures the percentage of time the brain stayed within the reward zone, and generates a detailed summary. This analysis will be helpful in future sessions. Selecting the target frequency requires careful evaluation of the client's baseline EEG or KEEG results. Each brainwave frequency is linked to a specific mental function, making neurofeedback both precise and personalized. For instance, theta reduction is used when clients struggle with excessive daydreaming or attention difficulties. By reducing theta, the brain learns to stay more alert. Alpha enhancement supports relaxation and emotional balance. This is particularly useful for individuals experiencing stress or anxiety. Beta training is used to improve mental clarity and focus, especially for tasks requiring sustained attention. SMR training, commonly seen in the YouTube sessions, encourages calm focus and improved impulse control. In many training games, movement occurs only when SMR increases, helping the brain build stability and control. These targeted frequencies allow practitioners to match theory with practice, identifying a brainwave pattern linked to a symptom, then training the brain toward a healthier rhythm. Now what results can we expect from the session? After neurofeedback training, clients often report a range of positive outcomes. Those working on beta or SMR frequencies may notice improved focus, clearer thinking, and better organization. Alpha training often leads to reduced anxiety, better emotional regulation, and greater calmness. Many clients gain a stronger awareness of their mental states, allowing them to manage stress more effectively. Over time, as the brain repeatedly practices healthier patterns, these improvements become more stable and long-lasting. As with any training, consistency is key. Neurofeedback effects build over multiple sessions, creating gradual but meaningful change. Electrodes or an EEG cap are placed on the scalp to collect electrical activity from specific brain regions. Conductive gel or paste ensures a stable connection between the skin and the electrodes, improving signal quality. Adhesive removal pads and tape are used along with the EEG cap if necessary. The EEG amplifier detects and strengthens the brain's electrical signals so they can be read accurately by the software. The neurofeedback software is the heart of the system. It analyzes EEG signals in real time, converts them into visual or auditory feedback, and records session data. A computer or laptop runs the software and displays the animations or games that provide the feedback. Finally, headphones or a monitor display deliver the feedback that guides the brain toward the desired activity pattern. How neurofeedback technology is evolving around the world. Today, neurofeedback systems have become more advanced and more accessible. Clinical-grade systems such as NeuroGuide, BrainMaster, and Thought technology are used in hospitals and therapy centers, offering highly detailed analysis and custom protocols. Home-based devices like Muse, Emotive, and Neurosky allow users to practice neurofeedback independently, bringing brain training into everyday settings. Artificial intelligence is becoming a major component of modern neurofeedback. AI systems automatically analyze patterns and personalize the protocol based on a user's performance. Virtual reality neurofeedback creates immersive environments, making training more enjoyable and engaging. Wearable EEG headbands now offer real-time monitoring of stress, focus, and relaxation throughout daily activities. These innovations demonstrate how neurofeedback is expanding rapidly worldwide, blending neuroscience with cutting-edge technology. Finally, let's wrap up with a summary and a look at the future. In conclusion, neurofeedback is a scientifically grounded method that empowers the brain to learn healthier patterns. By combining EEG technology with real-time feedback, individuals can improve attention, emotional stability, and stress regulation. Looking ahead, the future of neurofeedback is exciting. Virtual reality will create more immersive training environments. Educational settings may use neurofeedback to enhance concentration and memory in students. Mental health professionals may incorporate it into therapy for anxiety, PTSD, and mood disorders. Athletes and musicians may use it to achieve peak performance. With artificial intelligence, protocols will become more personalized and precise. And with wearable devices, neurofeedback may soon become part of everyday life for managing stress and optimizing cognitive health. Hence, neurofeedback represents a powerful intersection between neuroscience and technology, and it continues to evolve over time. Thank you for watching.